Module 1 in our first presentation on Module 1. As we get started with this course, I want to talk a little bit about design intent and part modeling, and that's what we'll be focusing on for Module 1, just to make sure you get into good habits in creating part designs. So design intent defines the ease with which a user can work with a solid model that has been created. Now, our goal is to create models with good design intent. Good modeling is not about your ability to just create models. Good modeling is about your ability to create models that other people can use, and that means you build them with good design intent. There's a list of items that support good design intent. One, for the most part, we'll be trying to work with fully constrained sketches. So what we want to do is ensure that all sketch elements are properly constrained, and if we have a fully constrained sketch, this makes the behavior of the model predictable. So particularly in this first module, we'll get in the habit of fully constrained sketches. And we'll also make use of proper constraints and dimensions. We can use constraints, which are in SOLIDWORKS are called relations, to define geometry when a dimension would be redundant. And these are things like tangents or parallels or perpendiculars. And we also want to use appropriate datums. And the definition of appropriate will vary from model to model, but a datum is basically where we dimension a part from, and the datums that we choose determines how the part behaves as we make changes to dimensions. We also want to make sure we make proper use of sketches and features. A couple things we want to be careful with is we don't want to overcomplicate a sketch. So a lot of times it's easier to make multiple sketches and multiple features rather than try to create all features from a single sketch. We also want to be aware of when we should do things as features or whether in the sketch. For example, features are usually easier to manipulate. One example would be a lot of times it's better and easier to create a pattern as a feature rather than using the pattern tool in a sketch. So these are some of the things that we will consider with good design intent. Some more things that go with good design intent. As we start modeling a part, you can have a plan. And so the plan includes identifying and working with the characteristic shapes of the model, what makes a natural front view, top view, right side view. You want to orient the model properly because most models do have a natural front, top, and side view. So make sure you create your part with the proper orientation in mind. It also is good practice to name our features. SOLIDWORKS assigns default names to features like Revolve 1, Extrude 1, etc. But we can change these, and it does not take much time. It can be a great time saver when you're looking for a particular sketch or feature to modify. We also want to be aware of the number of solid bodies in your parts. So sometimes we'll create parts that have multiple solid bodies. Usually they end up with a single solid body, so you might have to create multiple solid bodies as you're creating some parts and then eventually merge them into a single body. So we want to be sure the default on our features is to merge to avoid creating a separate solid body. And I think that is the natural default, but if it's not, you could run into trouble. Some more things with good design intent. Typically we'll add material to a model first, and then cut material. The reason for doing this is because if we add material after creating a cut, we run the risk of filling in the cut. So usually we add material and then cut later. We also want to avoid using cuts to fix problems. For example, you might create a part and say, oh, this part is too long. I'll just cut 2 inches off the end with the cut feature. That will fix the problem. If you try that, you might end up with something that looks like this. You have dimensions of 4, and then you've got a dimension of 8 minus 2, which gives a dimension of 6. And that makes no sense whatsoever because you've got 2 dimensions here, the 2 and the 8 that are just dimensions of space. And to a machinist, these are ridiculous. And so we want to avoid using cuts just for convenient fixes to models. The one time that we will tend to use cuts a little bit more heavily, but again still with caution, is when we want to define manufacturing steps. So sometimes we want to create a model and we start with just a solid block, and this will be one of our exercises. And we'll cut away material just in the same sequence if we were trying to machine the part, trying to give the machinist a sense or a picture of what steps might be taking to take a solid block of material down to the final part. But again, that's still the same process as we add material first and then cut. The only difference is that everything in a manufacturing step model is cut, cut, cut. And there are some SOLIDWORKS videos to watch that explain these. There are some design intent examples. There's creating a part with good design intent. There's modifying a part and why good design intent is helpful. There's a design intent for manufacturing or machining. And to go with this, we have homework to complete. There's a Lego block, a drain plug, a screwdriver handle, a Lego wheel, and a machined part. And also to know, if you want to pay attention to these, there are homework check videos. Basically, when I get your assignments, the check videos for the Lego block, drain plug, and screwdriver handle will show you exactly what I'm going to do to check to make sure you've created your model somewhat properly at least. And so make sure you look at those check videos before you turn in your assignments.